All right, so let's continue with section N8. This question says, quadrilateral EFGH is a rhombus. What is measure of angle EHF? Okay, so again, we know that rhombuses are parallelograms. The purpose of identifying that fact is that if consecutive angles in the rhombus, so this blue one and then this red one, this entire corner, they have to be supplementary. So the red angle, which is angle EHG, not the one they're looking for, just EHG for now, that should be equal to 180 minus 114, which is 66 degrees. So this whole red angle is 66. Now, one of the properties of a rhombus is that the diagonals, so HF bisects both angles H and angle F. In particular, the one we care about here is angle H. So HF bisects angle H, which implies that these two angles in green, the two halves, that these two angles are half of 66. So that implies that measure of angle EHF, which is the one that we're looking for, is half of 66, which is 33. Okay. And by the way, that the fact that the diagonals bisect the angles is also true for the other diagonal. So let's just draw it in here. This diagonal right here bisects that 114 degree angle. Also, opposite angles are congruent, so, which we already knew before, but just to reiterate, so this angle right here, angle F, the entire thing is also 66 as it is on the opposite side. Okay. So 33 is the answer. Let's plug it in, make sure. 33. Okay. All right, number 2. What is a measure of angle WYZ? WYZ. Okay. Let's do this one. Okay, so it's a rhombus, which means that the angle that we're interested in, WYZ, it's exactly half of the angle ZYX, which is the whole thing here, the whole red angle. Okay, now that whole red angle and this other red angle here, 72, those are consecutive angles within the rhombus. Consecutive as opposed to opposite, like these two would be. Okay. So they're consecutive, which means that they have to add up to 180. So this angle plus this other red angle has to be equal to 180. So we can figure out what the large angle is. So we can do 180 minus 72 is 108. Okay. Now the angle that we're interested in, the blue one, measure of angle WYZ is half of 108 because WY bisects the angle. WY is the, or YW is the diagonal. Okay, so then this is 54 degrees. So let's plug that in, make sure we're right about that. 54, yeah. Okay, what is the measure of angle STU? Okay, so we're looking for STU, which is this angle right here. So this angle 36 is given. Since it is a rhombus, this diagonal that I'm highlighting in blue bisects this larger angle Q. So that means that this red angle here, which is made from this side of the rhombus and this, the diagonal, is 36, then so is this side. So that's 36. Okay, let's clean up some of this stuff. Okay. So the entire black angle is 36 plus 36, which is 72. Okay, so 72 for the black portion. Now, that black angle and this black angle, those are consecutive angles in the rhombus. Right, so remember what consecutive means. We got a rhombus here. These two are consecutive, as opposed to these two that are opposite. Okay, so they're consecutive angles, and we know that consecutive angles in parallelograms, so also in rhombuses, should add up to 180. So if that black angle is 72, so this should add up to 180. So if we do 180 minus the 72 from the black angle, we're going to get 108. Okay, so this black angle over here is 108. And then finally, to get the blue angle, it's going to be half as much, because TR bisects the 108 degree angle. Okay, so we can calculate the blue angle, which is STR. So measure of angle STU, well, I guess both would work, STR or STU, is equal to 108 divided by 2, which is 54. Okay, so let's plug that in. There you go. Okay, I think U, V, Y. This is a similar process here. Let's jump up a level. Okay. Looks sufficiently different. Let's do this one. Quadrilateral HIJK is a rhombus, HIJK, and measure of angle IKJ. So this angle right here is 3T. What is the value of T? Okay. So we've already seen that given this angle, 66, we should be able to figure out what the blue angle is. We should be able to figure out that angle. And then whatever it's equal to, well, let's go ahead and figure it out. So if this is 66, then this larger, this red angle, that whole thing, K, so JKH, so this red, so angle JKH, so measure of angle JKH plus angle J, these two red ones, they're supplementary because they're consecutive angles in the rhombus. Okay, we already have 66 for this one. If we want to figure out measure of angle JKH, we just subtract the 66. So minus 66 minus 66, and we get the measure of angle JKH is equal to 114 degrees. So this red angle is 114. That makes this half equal to 114 over 2, which is 57. Now at the same time, it's called, it has a mathematical expression 3t associated with it. So 3t is 57 degrees. And then we can divide this by 3. Divide by 3, this cancels out, and we get t equals 19. So t is 19. And let's plug it in just to make sure. 19. Okay. I think this is kind of similar. I could have sworn there was a different type of question in this. I don't think we've done one like this, but it's pretty simple though. If this is a rhombus, and that means that this length is the same as this one. So you can just set 3p equal to p plus 12. And you can solve that for p. Okay. Delete. All right, let's go to N9. Okay, properties of squares and rectangles. Okay, so it's telling us that this is a square. What is TV? Okay, so when we talked about parallelograms, we learned that the diagonals bisect each other. So whatever this is the same length. Now a square is a type of parallelogram. So that means that that information also applies to this square, which is why I went ahead and put the marks, saying that those two line segments are congruent. Okay, so if that's 65, then this is 65. And if they want to know the length of TV, you're just going to add the 65 from one half to the 65 from the other, and that gives us 130. So let's plug in 130. Yeah. Quadrilateral RSTU is a square. What is the measure of angle SRV? SRV. Okay. I'm going to give a little bit of extra information just to sort of give you as many sort of corroborating facts as possible. Corroborating is kind of like, it's like consistency. Usually that corroborating is reserved for like, I don't know, like a trial, like whether the witnesses give testimonies that sort of, they're not contradictory. So what I just mean is I'm sort of going to review old information and show you how it still works now in the square. So a square is a type of parallelogram, and we learned about parallelograms that consecutive angles, so this entire blue angle S and this entire blue angle R, they should add up to 180. Now on the other hand, we know that this is a square and that this should be 90 degrees also. All four corners should be 90 degrees. And if you just think about that, if this is 90 and this is 90, then look at that. That adds up to 180. So just kind of showing the consistency between all the different facts that we've talked about. Okay. Now, they don't want either the blue angle or the red angles that I've drawn. They want SRV, measure of angle SRV. SRV is just, I'm going to have to erase some stuff. Well, I could probably just zoom in. Let's just zoom in. SRV is just this green angle right here. Now, we talked about rhombuses in the last section. A square is a rhombus because the four sides of the square are all the same length, which is the definition of a rhombus. Okay. So since it's a rhombus, one of the things that we used in the last section about rhombuses was that the diagonals bisect each other. So in particular, this diagonal right here, this is R, this is T. That diagonal bisects this 90-degree angle. That means that these two green angles should be half of 90. So 90 divided by 2 is 45. So that angle is 45 degrees. Okay. So let's plug that in. 45, submit. Okay, what is the measure of angle FHG? Notice that we don't have any numbers here. And the reason we can still answer these questions is because the square, there's a lot of restrictions of what a square is. Or, you know, we get a lot of details when you say something's a square. So, like, we know so many things. One of the things is that all four of these are 90. All of these are the same length. The diagonals bisect each other. Even more, the diagonals are all the same length, so we can actually erase this 2 and just say that they're all the same length. The diagonals bisect the angles, so that angle is the same as this one, and this angle is the same as this one, and this one, and this one, and this one, and this one. We got a lot of things. FHG. Okay, so we kind of did this one already. This is 45 degrees. There's another thing that we haven't talked about yet, which is the angles at which the diagonals intersect. So I'm talking about this angle right here, this one, this one, this one. We haven't talked about that yet. That'll come up soon. Let's see. Let's keep going. So this should be 45 degrees. All right, so what is the value of x? Well, since it's a square, we know that those two sides have to be the same length. So you would just set 3x equals to x plus 44 and solve the equation. I'm not going to do that one. Let's jump up a level. This one's saying Fi is the same as Gi. I'm sorry. They're saying that Fi is a plus 20 and Gi is 3a minus 90. What is the value of a? Yeah, I said that they're equal. That's true. They are equal. So, yeah, so let's review this really quick. This is not pertaining to the angles. Like, it's not pertaining to these angles. But I think it's worth reviewing. So, we've talked about parallelograms. And we talked about the fact that the diagonals are not the same length necessarily. Notice the green one is shorter than the red one. But they at least do bisect each other. So whatever this is, and whatever this one is also. Now, if you change the parallelogram into a rectangle. So this parallelogram gets sort of turned upright so that all these angles are 90. And we consider the diagonals of a rectangle. I'll just do them both in red. Not only do they bisect each other so that these two are the same and these two are the same, but even or more than that, they're actually all equal to each other. The lengths of the two diagonals are the same, unlike in the parallelogram here. Okay, and that's also true inside of a square. So if we had a square, the diagonals would bisect each other. Whoops. And all the lengths would be the same. Okay, so at least for this question, all we have to do is say that a plus 20 is equal to 3a minus 90, which is that this line segment is the same length as this line segment. So if you didn't know this about a rectangle, then you might have seen this diagram and been like, well, I don't know. I mean, if you would have told me to find A when and A was associated with these two line segments, then I would have done it because I know that the diagonals bisect each other in parallelograms. But in rectangles, you get the extra added detail that actually all four of these are the same as each other. Okay, so you just have to solve this equation. So we're going to subtract A, this cancels out. We got 20 is equal to 2A minus 90. And then we're going to add 90, add 90. So we get 110 equals 2A, which implies that A is 55. So this is 55. Let's plug it in and make sure. Okay. These two are equal to each other. Let's go up a level. AC and BD, the diagonals are congruent to each other, so you can just set those expressions with P equal to each other. So you would have to try to solve the equation 3P minus 71 equals 2P. Okay. E, F, G. We've done that. Is this a parallelogram? I'm sorry, is this parallelogram a rectangle? This is worth going over. This is also kind of another converse thing. So I just told you that if you have a rectangle, then all four halves of those diagonals, they're all equal to each other. It turns out that the converse is true. That is to say, if you come across a figure like this one, and you notice that the four halves of the diagonals are all congruent, then that does in fact mean that it's a rectangle. Okay, so this would be a yes. Let's jump down. I just want to make sure I'm not missing a question about the angles at the intersections of the diagonals. This has to do with length. Okay, I don't think I'm missing anything. So let's go. Maybe it was in another section. N10. Properties of trapezoids. Yeah, this is totally different. Okay. All right, so it says V and S are the midpoints of the legs UW and TX of trapezoid TUWX. If WX is 23, so if this is 23, and SV is 31, this has a length of 31, what is TU? Okay. I don't know why this is true yet. We'll probably figure it out. I think we have to go into similar figures to figure out why this works. But, so I'll just go ahead and show you what the relationship is. So when you have a trapezoid, it turns out that this line segment, so notice that it said that V and S are midpoints. So V and S are midpoints. When you draw the line segment connecting those two, which we know has a length of 31, that turns out to be the average of these two opposite sides of the trapezoid. So when I say average, I actually literally mean what you guys learned in elementary school probably about averages. So it's the average of WX. Okay, so VS, well, the length, so just VS is equal to equals the average of the lengths of WX and UT. So VS is equal to, how do you find the average? You take the two numbers, WX, add them together, so WX plus UT, and divided by how many you're considering, which we're only considering two numbers, so we divide by 2. Okay. So VS is equal to, oh, sorry. So in this case, they tell us that VS is 31. And the one that's missing is actually one of the ones up here. So we're going to have to be able to solve for that. Yeah, so let's go ahead and plug everything in, just make sure that we only have one unknown. So 31, and then WX we have as 23 plus UT over 2. Okay, so there's only one unknown, so we should be able to solve this. The way you solve this type of equation is you're going to multiply both sides by the denominator. So times 2, that'll cancel this out, and times 2 over here. So we get 62 is equal to 23 plus UT. And then subtract 23, subtract 23. This cancels out. And we get 39, I think. So this is 39. One way to check is if the difference between these two is the same as the difference between these two. And the difference here is 8, and the difference here is 8. 39 minus 31 is 8, and 31 minus 23 is 8. So that just verifies that 31 is the average of 39 and 23. Okay, so we should get 39 here. So let's go ahead and plug it in. Okay, this is the same thing. Let's notice what it's called. It's called a mid-segment. Kind of like, it's very similar to when we did the mid-segment of a triangle. QT is called the mid-segment. Let's just find one that is asking for PS. What is the value of Y? Oh wow, this looks hard. This looks different. So let's go back, find the one that I was looking for, and then we'll do one of those. UV, no. PS. Okay, what is PS? Okay, so here they're actually looking for the one in the middle. They're looking for the mid-segment. But again, the one in the middle, PS, is equal to the average of the other two. So you would take UT plus QR and you would divide it by 2. And now we can just plug everything in. So we're going to get PS is equal to UT is 70 plus QR is 32 divided by 2. PS is equal to 102 over 2, which is 51. Sorry, 51. Okay, so PS is 51. Let's plug it in. Submit. Okay. What is this? If DG is not parallel to EF, what is DG? Okay. So this is just testing you on like the definition of a trapezoid. Because they already told us that FG, like if you look at the diagram and you look at the marks, the arrows, it's telling you that FG is parallel to ED. So when they tell you in words at the top that DG is not parallel to EF, they're just making it clear that there's exactly one pair of parallel sides. So it's definitely a trapezoid. You don't have to, because you know how we do in geometry, we can't really assume much. Even if the diagram looks a certain way, you can't really assume it. So what they're doing here is they're just being absolutely clear that there's exactly one pair of parallel sides. So you can come to the conclusion that for sure it's a trapezoid. And then this is an isosceles trapezoid where those two base angles are congruent. So right here, G and F are congruent. And then that implies that these two sides have to be congruent. So DG is just 20. It's the same as this one. Okay, let's go back to that other problem. Isosceles trapezoid. Well, this is not like that other one, but okay. So let's do this one. This is an isosceles trapezoid. So this angle here is the same as this angle here. They're asking us what is B if we know that the measure of angle X is equal to 3B. 3B. All right, so this is, these two are congruent to each other. So we have 3B is equal to 129. So divided by 3, we get B equals 43. So let's plug that in. Oh, we got lots of different questions here, different types. Okay, TV is 6W plus 8, and UW is 7W. So for isosceles trapezoids, the diagonals are congruent. So this is congruent to this one. Okay, so since they're congruent, we could just say that these two equal each other. And you could solve this, so subtract 6W, this cancels out, and we get 8 equals W. So that would be 8. And I really want to see one of those other questions that we got about the mid-segments. Yeah, like this one, but with all of the FH, GI, same kind of thing. Yeah, like this type, but with all the variables. Okay, here we go. Okay. So we know the relationship between the mid-segment and the other two sides of the trapezoid. That is that SV should be the average of TU and QR. The average being the sum of the two divided by 2. Okay, but now notice all the stuff they give us. They tell us what TU is, SV is, and QR is, but in terms of x. So we have to plug all of those into this equation. So that's going to be kind of nasty. So SV is on the left. It's negative 4x plus 87 equal to TU is 5x minus 20 plus, let's put the plus sign in black just to emphasize that that's this plus sign right there. And then we got 3x plus 34 for QR. And then we have 2 on the bottom. Okay, the left I'm going to leave alone for a sec. On the right-hand side, we can combine like terms on the top. So we got 5x and 3x is 8x. And negative 20 and 34 is positive 14. So we end up with that on top. Okay. So we have to isolate x. Unfortunately, there's x's on both sides. Now, you guys already know, well, I've already shown one way to handle this. Well, it's going to be pretty different, actually. So let's actually, I'm going to do it 2 different ways. So let's do it similar to what I did before. So let's do, you're going to multiply this fraction times the denominator. It cancels this out. But you got to multiply this side by 2 also. Now you got to be careful. And when we do algebra and we say that you have to do the same thing to both sides, you have to do it to the entire side. So you're multiplying the entire thing, which means, and the implication of that being that we have to distribute this. So when we multiply this, we're going to get negative 8x plus 174 equals, on the right-hand side, we cancel the denominator, so we're just left with the numerator. Uh-oh. Oh, never mind. I thought I made a mistake. I thought the 8x's were going to cancel, but they're not. That's why I write everything out, because I always make mistakes if I don't write it out. So here, this will be plus 8x, giving us 16, not 0, like I thought was going to happen. Okay, so this is 16x plus 14 equals 174. Subtract 14, and we end up getting 160 equals 16x. Divide by 16, this cancels out. X equals 10. So we should get 10 here. Okay, so that's enough for N10. Let's do N11. Properties of kites. Okay, quadrilateral QRST is a kite. What is the measure of angle Q? Okay. So, for kites, the angles made from the 2 sides that are not equal, so notice this is not equal to this one, and this angle on the left that's made of these 2 sides that are not equal to each other. That's opposed to, like, for example, this angle, which is made up of this side and this side, which are equal to each other. Okay, just to contrast. So these 2 angles are congruent to each other. Okay, and they're asking for what the measure of angle Q is. Okay. Well, a kite is a quadrilateral, and we learned at the beginning that quadrilaterals have 360 degrees total in the interior angles. So So we can write an equation, or you can do this. A lot of you will be able to do this in the calculator. You would literally just write 360, subtract the 141, subtract the 81. That'll give you what's left over for S and Q. And then you would just divide that by 2, since S and Q are the same, to figure out what one of them is. And then that'll give you the answer. Okay, but what I want to do is write out an equation spelling out the relationship between the 4 angles. So what's the relationship between the 4 angles? The relationship is that they all add up to 360. So angle S plus angle Q plus the angle that's 141 degrees plus the angle that's 81 degrees should equal to 360. S and Q are equal. So we can just call this angle Q since it's the same thing. So now we'll bring this one down. So now we got angle Q plus angle Q. The reason I substituted for Q is because that's what we want to find. We want to find Q. I could have made this one S, but I mean, and they're both the same. So even if I wrote S and got that number at the end, you could still write that as the answer. Okay, and then 141 plus 81 is 222 equals 360. Okay, so then that gives us 2 measures of angle Q plus 222 equals 360. Subtract 222, subtract 222, this cancels out, and we get 2 measures of angle Q is equal to 138. And then divide that by 2, and that'll give us that. Just 1 Q is equal to 69. So 69 degrees. Let's plug it in. Okay. What is the measure of angle H? This is the same thing. Those 2 missing angles are congruent to each other. Okay. Let's go up a level. Okay. This is what I thought we were going to come upon for rhombuses. But, okay, it came up here. No problem. So for this, they're asking for the length of TU. And we know SU and ST, and they tell us it's a kite. So one of the properties of a kite is that the diagonals, so SQ here and RT, they intersect at exactly 90 degrees. So all these 4 angles are 90. In particular, that one right there is 90. And the reason that's going to be useful is because that makes triangle SUT a right triangle. A right triangle where we know 2 of its parts. We know this side is 40, which is the hypotenuse, because it's the side opposite the 90-degree angle. And we know this side, which is one of the legs. And we're being asked to solve for this other side. I'm not so sure we've done the Pythagorean theorem this year, but you guys have done it in the past. We have a relationship that relates the 3 side lengths of right triangles, and that's the Pythagorean theorem. The Pythagorean theorem states that if you have a right triangle, then a squared plus b squared equals c squared, where c represents the length of the hypotenuse. Just c alone, not c squared. Okay. So like if you wanted to know what the hypotenuse was, you'd have to solve for c. You'd have to isolate c, and you'd have to undo that exponent of 2. And same thing with all of these. If you wanted to know what the length of side A was, you would have to isolate for A, including getting rid of this exponent of 2. Okay, so let's see how we would do that. So in this case, if we try to plug in the information that we have, the hypotenuse is 40. The hypotenuse has to go over here by itself on the right-hand side where the C is. The other 2 legs can be plugged into A and B in whichever order you want. So let's plug in the 24 into A. And then we got plus, one of them is unknown, so we're just going to leave the variable there, b squared. Okay, so now we have to solve this. You cannot do the following. You cannot do this. Don't do this. You cannot make this 16 and then find the square, because 40 minus 24 is 16. You cannot do that. You have to actually find the square of these. So you have to find out what 24 squared is. I need a calculator for that. 576 plus b squared equals, this is 1600. Okay, and then now we can subtract. So this leaves us with b squared is equal to 124. Okay. So now we got what b squared is. B squared is 1024, but we don't want to know what b squared is. We want to know what just b is. So the question is, let's rewrite this over here. So the question is, how do we isolate the b when it's being squared? The opposite operation for squaring is taking the square root. So we would take the square root here, take the square root here, and in the end, we'll get b equals, I think this is 32. Okay, so 32. 32 is the length of side UT. So let's plug that in. 32. Yeah. This is the same thing. For kites, the diagonals intersect at 90 degrees. So triangle EGF is a right triangle, and its hypotenuse is 20. And you would plug in the 20 and the 16 into the Pythagorean theorem, and you would be able to figure out what EG is. That would also give you the length of GC. So they might, in a sort of roundabout way, they might ask you for GC, even though it looks like the values they gave you are for the wrong triangle. But it's the same as EG. Okay. All right, let's see if there's anything else in this. Measure of angle V, we talked about that. Okay, let's go to N12. N12, review properties of quadrilaterals. quadrilateral BCDE is an isosceles trapezoid, and measure of angle C is equal to 8A plus 54. What is the value of A? Okay, so this section is going to be good because it's going to bring together everything that we did in this section on quadrilaterals. So one of the bad things about IXL, at least from a teacher perspective, for you guys, you probably like it, but it's that you kind of get the same question like over and over and over again, and you pretty much do the same thing every time. So I like when IXL does these review sections because you don't really know what section it's coming from, and you really have to try to think back to what you did in that section. Okay, so let's do this one. This is an isosceles trapezoid. So, well, actually, do I really have to do this section? I mean, we've already done this, right? You guys know that this is an isosceles trapezoid. Then whatever this angle is the same amount. So this should be 126. So that's 126 equals 8A plus 54, and then you would solve for A. And that's it. I don't think I have to do this section because, so what I'll do is I guess I'll just go through and see if we get anything weird that didn't pop up in the sections. Is parallelogram VWXY a rhombus? This is a good question. Oh. Actually, that's different than what I thought I was asking. So, is this parallelogram a rhombus? Yeah. Oh, perfect. This is what I was trying to get to, that they never actually asked, which I thought they asked in one of the sections. So now we get to talk about the angles in here. So for a parallelogram, which is like the least specific, the quadrilateral with the least personality that we learn about. Well, I mean, I guess except for quadrilateral itself. But we know very little about these, right? Usually they're just told that the opposite sides are parallel or they're congruent. Okay. So, well, first of all, we already know that this angle and this angle are congruent. And that's got nothing to do with the fact that it's a parallelogram or this is the quadrilateral section. It's got nothing to do with that. We've known that for a long time in this class. Those two are just vertical angles, right? Anytime you have two angles that intersect, the two opposing angles, they're congruent to each other. So those are congruent because they're vertical angles. Okay. These are also congruent. This one and this one. But they don't all four have to be equal to each other. Okay? So in a rhombus, in a parallelogram, let me just make sure everybody knows this is a parallelogram that I'm talking about at the moment. This blue one. The four angles in there created by the two diagonals intersecting, those don't have to, all four of them don't have to be congruent. Now, let's look at a rectangle. And I exaggerate some of these shapes just to really make clear in the picture that it's, that it's working a certain way. So let's... Okay, let's draw the other one. Whoops, changed color. Okay, so even in a rectangle, look how wide this angle is. Super wide. And look how small this angle is. Okay, so although these two are congruent to each other, those two angles. These two and these two little ones are congruent to each other. The four of them together, not all four of them are equal to each other. Okay, now, but let's look at two other ones. So this is a rectangle. Let's look at two of the other shapes we've been studying. Let's do rhombus. Well, this is a rhombus, so we'll talk about that one there. Let's do square. If you have a square, and you draw the diagonals, then actually, yes, not only are these angles congruent to each other and these angles congruent to each other, but furthermore, actually all four of them are equal. So they're all the same. And actually, they're all 90. So this is 90, 90, 90, 90. Okay, that's true for every square. It turns out that that's true for a rhombus. So these are all 90. And it turns out that the converse is also true. If you run into a... Oh. Yeah, it is. Interesting. Okay. So it turns out that if you run into, well, I was going to say a quadrilateral. If you run into a quadrilateral like this one that they have drawn, and you notice that all four of the angles created by the diagonals are 90, all four of these blue ones, then that implies that it's a rhombus. But that's not actually true. But that's not what they're saying. They're saying if you run into a parallelogram, and you find that all four of those angles created by the diagonals are 90, then it's a rhombus. That is true. Okay, now let me tell you about the last shape that we've talked about, which is a kite. So the kite example is going to show you it's going to explain what I mean. Like the difference between if they would have said parallelogram up here or if they would have said quadrilateral. So a kite, I'm going to try to draw it in the same orientation. Okay, so if you draw the diagonals of a kite, this is not going to be perfect, but all four of these angles are 90 degrees. And we actually used that in the last section, right? Because they would tell us like this is 20 and this is 18. What's the other side? And we used the fact that these were right triangles to use the Pythagorean theorem. So let's look back at the question. Notice the claim. The claim is parallelogram VWXY a rhombus? Now, these two pictures look kind of the same. Is this a rhombus? The kite is not a rhombus. And yet, we run into this situation where those four angles created by the diagonals are all 90 degrees. And same thing happens when you have in the case of the square. All four angles created by the diagonals are 90 degrees. And this is a rhombus. The square is a rhombus, and the actual example in this question is a rhombus also. But not this one. This is a kite. So if they would have said quadrilateral up here, like if they would have asked you, is quadrilateral VWXY a rhombus? So if all we knew was that this thing was a quadrilateral, like who knows, maybe it would be kind of like this. Like you wouldn't exactly know how long this line segment is versus this one. Right? If you didn't really know, then you couldn't really say it's a rhombus. Like in the end, you wouldn't be able to say, yes, it's a rhombus. But because they told you it's a parallelogram, all right, let me erase some of this. This is getting crazy. But because they tell you it's a parallelogram, that forces this side Oh, hold on a second. I was going to say it forces these two sides to be congruent, but that's not even true. Parallelograms imply that this side is congruent to this opposite side, and this side is congruent to this opposite side. Oh, no, yeah. Yeah, I'm right. So it is a rhombus. The fact that they tell you it's a parallelogram is what allows you to conclude it's a rhombus, and not maybe a kite. It doesn't have a chance to be a kite. It's definitely a rhombus. Okay, so let's press yes, and let's see if we're right about that. Yeah, and the key there is that they said it's a parallelogram. If they would have just said a quadrilateral, then there's still a chance that it could have been a kite, and you wouldn't. Then the answer would have been no. Okay, is this parallelogram a rectangle? So again, the fact that they're telling you it's a parallelogram means that this side has to be the same as this side, and this side, these two sides have to be the same. Okay. And then what we see here is that, yeah, the diagonals bisect each other. That's what this marks tell us. But they're not all four are equal to each other. This is 87 and this is 98. But for rectangles, they should be. For rectangles, they should be. So this is not a rectangle. Okay, delete. No. Is parallelogram GHIJ a rhombus? GHIJ a rhombus. So rhombuses, they have the property that consecutive angles are supplementary. They also have the property that opposite angles are congruent. So, and we have that here. This angle is congruent to this one. This total is congruent to this total. Okay. Now, but that's true for parallelograms also. Parallelograms is not as strong of a statement as a rhombus. So that's also true of parallelograms. We need to determine more information to make sure that this is a rhombus. We need to make sure either that all four sides are congruent, or that the diagonals bisect each other. Sorry, not that the diagonals bisect each other. That the diagonals are angle bisectors, which in this case, these two are. That's what the fact that they have this one line here and one line here, that implies that HJ, this line, bisects this larger angle into these two smaller red ones. Okay, so this should be a yes. All right. This can't be a square because those two parts of the diagonals are not the same. So this is a no. Okay, so that's it for N12. And I'm going to take another break and we'll do 13 and